So guys, let's get the show on the road. So basically, we are going to look today at what fractions are. So can anyone put on the chat for me, or you can raise your hand at this point, what is a fraction? Why do we use fractions? You can type it out. Listen, what are fractions?
Fraction are numbers of denominator.
Oh, what happened?
Fraction are number of denominator and numerator.
Okay, perfect. So fractions are made up of a numerator, a number at the top, and a denominator, a number at the bottom. That's awesome. So fractions are two parts or have two parts to them. And guys, what we essentially need to know is that fractions make up parts of a whole, or multiple parts of multiple wholes. So make up or represent, if you want to say, parts of a whole. And we can use fractions to represent multiple whole values, multiple whole numbers, and then a fraction part. So fractions allow us to represent a value that isn't completely a whole, so isn't completely one whole thing or value, but part of it. Okay, so if you have a look at your little picture down here, you can see what that means as a visual representation. So here we've got our blocks, and we've got one block shaded in. Now, in total, I have got 4 blocks. And so as a fraction, we can say we have got 1 out of 4 shaded, 1 out of 4 shaded regions. Okay, so essentially fractions allow us to represent these parts of a whole. As Blessed said, a fraction rather is made up of a numerator, which is the top number, and a denominator, which is the bottom number. And we'll chat about what all of this means as we start to practice our fractions. But you can see that the denominator represents how many parts in total make up the whole, and the numerator represents the specific part of the whole that I'm talking about. So here, the 1 represents the 1 shaded block, and the 4 represents how many blocks I had in total. Okay, so as we start to go through this, as Brian's asked on the chat there, we will start to talk about common denominators, etc., but we will talk about that when we get to that specific lesson. Not today, but we will talk about it. Right, so guys, that is a fraction. I'll just wait here for a second or two if you want to take a screenshot of this. And then we're going to just chat about the different formats and the different ways we can write fractions, being able to convert between fractions or types of fractions rather, and just understanding how we actually need to be able to work with these fractions when we start doing operations or calculations. Right, Brian said I'm lagging, so I'm just going to turn my camera off. Hopefully that's going to help.
Yeah, I'm not sure whether it's your earphones also, because we hear the sound of every single time. Not that you are lagging, as in like you are cutting and then not cutting. No, it's more of like there's some noise of. So I'm not sure if it's your earphones.
Okay, let's see if we can figure this out.
I take screenshot, my people. It is a very nice summarized way. Okay, and don't worry, you will understand much more in details because Teacher Sam will do many examples about this so that you can understand better. Okay, guys.
Yes, okay, can we hear me better now?
Yes. Okay. I think I
Okay.
can hear Teacher Sam way better now. So please do comment. Teacher Sam, you can talk so they can hear.
Okay, I'm hoping we're all hearing me better. Yes, I've turned off my camera. I just wanted to see if that would help, but it seems we've figured out the problem. So new headphones it is. The screen should not be blinking blue. So if it is, you might need to log out and log back in again to figure it out. Guys, remember, please only raise your hand when I ask you to raise your hand for questions or for answers. And remember that when I do pick on you, you've got 5 seconds to answer. Otherwise, I move on to the next person. I just remembered that I didn't actually say that. So remind you while you're taking screenshots. Okay, so let us have a look then at these types of fractions that we need to be comfortable with. So the first format of the fraction that we're going to work with are mixed numbers. Now, mixed numbers, I like improper fractions. That's the fraction I like. But mixed numbers sometimes come up, and they're very useful to us to understand better when we're working with more than just one whole and then parts of the next whole. So mixed numbers will have 2 parts to it, similar to a fraction. A mixed number will have a whole number part or an integer part, and then it will have the fraction part of its number. So this whole number, this mixed number that we're talking about here is 2 1/5. So if we think about what that means, my drawings are not going to be beautiful, but it's okay. We move. The 2 in front, so that whole number portion of my number, represents 2 wholes. So the entire shape that I'm working with, I'm considering as that 2. It is my whole number, it's 2 whole parts. The fifth, or the fraction part, is now where I'm only considering part of the next whole. So this final rectangle could be split into 5 parts. You can split the other rectangles into 5 parts if you want, but you're considering the whole thing, so it's not entirely necessary. And the fraction now represents only 1 part out of those 5 parts. And so the mixed number allows us to represent multiple wholes and then part of the next whole. Now, this is useful to us because it is in a format that is a little bit easier to understand. If I say 2 1/2, that's a little bit easier to understand than, say, for example, 11/2 or whatever as an improper fraction. So mixed numbers just allow us to understand better exactly how much it is that we're working with when we're talking about whatever parts of the whole that we are with. Okay, so excuse me, mixed numbers written in a specific format with a whole number and a fraction part, and like I say, represents multiple wholes and then part of the next whole. Now, what we need to be able to do is we need to be able to convert between fraction formats. And one of the conversions that we need to be able to do is to convert from a mixed number to an improper fraction, which is what Brian is talking about on the chat there, as well as from improper fractions to mixed numbers. Okay, so we need to be able to go between both, and I'm going to show you how to go between both if you don't know, so don't stress. Let's first talk about what an improper fraction is. So an improper fraction gives us the same information about as a mixed number. It tells us that we're working with multiple wholes and then parts of a whole, but we just written in a slightly different way. Now, improper fractions is when our numerator is bigger than the denominator. So the top number is bigger than the bottom number. And the denominator. So remember, numerator is at the top, denominator is at the bottom. It would help if I could spell bottom. Okay, so the top part will always be bigger than the bottom part, and this is because we're representing multiple wholes and then a portion of the next. So as you can see here in my example, we've got an improper fraction of 7/2, but this means exactly the same thing in a mixed number format as 3 1/2. Now, if we think about this visually or as pictures, excuse me, there are my 7 parts. So that's representing my numerator. And as you can see, each of them are half a circle. Now that half a circle is representing the 2 in the denominator. 2 represents 2 parts. So each of these parts is representing one of those 2 parts. And now when I start to put them together, as you can see in my diagram, I'm forming full circles, and I form 3 full or complete circles. And that represents my whole number 3. And then I've just got one little half moon or half circle left over, which is why I've got a half as my fraction part of my mixed number. Excuse me. So this is why an improper fraction will always have a bigger numerator. It's representing multiple wholes, like I've said, and then a fraction part, and we need to be able to go between the 2. Now, you don't have to draw pictures like I've done over here, but it could be helpful to you. It's really dependent on how you, I suppose, learn. I'm going to show you a little trick of how to convert, but essentially, like I say, an improper fraction does the same thing as a mixed number. It's just a different way of writing it. So if we think about that in terms of these blocks that I've drawn up here, your denominator will always be how many parts the shape or the picture that you're working with is broken up into. So we saw here each of my rectangles, although I didn't do this one very well, was broken up into 5 parts. So that's my denominator. And then if I want to figure out what my bigger numerator is going to be, I see how many parts are shaded in. So in my first rectangle, all 5 parts are shaded in. In my second rectangle, all 5 parts are shaded in. So that's now 10 parts. And in my third rectangle, I've only got 1 part shaded in. So that would give me 11 over 5 as an improper fraction. And so like I said, they do the same thing. They give us the same information. Mixed numbers and improper fractions are just different ways of writing the same information. All right, so I'm going to stop here in case you want to take a screenshot, and then we're going to start looking at how we can start working with these fractions and eventually start doing those conversions. While you are taking screenshots, if anyone has any questions, now is the time to raise your hand and ask me. And let's make sure we're all comfortable and confident before we move on.
Let's go, my people. Take screenshots. If you are confused a little bit, raise your hand so you can ask, please. Okay, going once, going twice. Okay, my people. Oh, Brian's there to ask.
Brian, what's your question? There should be a little pop-up to unmute yourself. Brian, you there? There we go.
To turn a improper fraction into a mixed number, do you need to divide the denominator with the numerator?
Say that again. To turn a
improper fraction into a mixed number.
Yes.
Do you need to divide the numerator with the divide the denominator with the numerator?
So yes, we'll divide the numerator by the denominator, and then we'll figure out what is remaining, and then that will become our fraction part. We are going to chat about it, so don't stress, but yes, there will be a division operation that we need to do. Okay. Sekofatso, where did the 2 come from on the improper fraction? So the 2 basically came from, if you go from the mixed number part, if we go, oh, sorry guys. If we go backwards almost, I suppose, if we look at this mixed number, our denominator that we're working with is 2. So the picture that we're working with is split into 2 parts. So there's 1, 2, 1, 2, 1, 2, and then I've only got 1. So because I'm breaking up my whole into 2 parts, that's where my denominator is coming from. And so if we then count how many of these half moon things I have in total, there's 7 half moons, and my denominator 2 represents that I split my whole into 2 parts. Alrighty, so that is where that denominator comes from. It's similar to the mixed number example that I did just at the top here. We split our rectangle into 5 parts, and so my denominator was 5. Alrighty. So I'm assuming we've all got our screenshots. So let's start having a look at how we can work with these fractions. So the first thing that we need to understand, guys, is that sometimes the same, no, let me rephrase that. Sometimes two different fractions can represent the same amount or the same part of the whole. So if you have a look at the pizzas that I've got down here, we have got four different pizzas, or pizzas cut into 4 different amounts of slices, but we can see that each of these fractions look different. All right, so if we have a look at our first picture, this is now, again, if we think about the denominator situation that we were just talking about, we have got one pizza that is cut into 2 halves. So we've got 1, 2, only 2 pieces, massive pieces of pizza, but we've only got 2. This shaded region is representing half of my pizza. So if I ate the shaded region, I would eat half of the pizza. If we then move over onto our next image, my pizza is now cut into 4 slices. But if I eat the shaded part of my pizza, I'm eating 2 of the 4 parts. But if you look at it visually, I'm actually eating half of my pizza. If I then go to the next image, and we're going to keep going like this. So if I go to my next image, I've now got a pizza with 8 pieces. 3, 4, 5, 6, 7, 8. We got there. 8 pieces. And if I consider the shaded pieces as the pieces I eat, I'm eating 4 of the 8 pieces. But if you look at the picture, I'm eating half of the pizza. And this is essentially what equivalent fractions are. So here in the last one, I'm not going to number all 16 pieces, just so we're all aware. But what we can see is we've got 16 pieces in total, and I'm eating 8 of those pieces, which means that as a fraction, I'm eating 8 out of 16. But if I look at my picture, I can see that it's half of the pizza. And so an equivalent fraction is exactly that. It's fractions that look different, but represent the same thing. We'll put that there for ourselves. Fractions that look different, but represent the same amount. Oh, my fingers in the camera. And so if we go back to our pizzas, all of these fractions, a half, 2 over 4, 4 over 8, 8 over 16, actually represent half of my pizza. All right, so equivalent fractions are exactly that. Fractions that look a bit different, but actually represent the same amount. And we're going to chat about how we can find equivalent fractions as we go along. And this is sort of going to lead us into being able to work with common denominators and so on. So I'm going to leave that there in case you need to take a screenshot. If you have a question, please raise your hand. Otherwise, after I've waited for like 10 seconds, I'm going to move on. And guys, remember, while I'm talking, because there's no hands while I'm talking, if you do have questions, please just raise your hand and type, no, please don't raise your hand. If you have a question, please type it in the chat and we will help you. Alrighty. Nigel, question? Nigel, are you there?
Nigel, we cannot hear you, so B. Okay, I'm not sure what that is, but we cannot hear you. So you can definitely just type your question on the chat. Okay.
Just pop your question on the chat for us and we'll help you like that. Alrighty, guys. So let's have a quick look at how we deal with equivalent fractions, and then we'll take a little brain break before we carry on. So equivalent fractions, like I say, they need to represent the same parts of the whole. That is what they are. Now, when you're trying to find equivalent fractions, what you can see from the pizza slices over here is that to get from one fraction to the next, I need to perform some sort of operation. So if I consider the 2 denominators of 2 and 4, if I multiply the 2 by 2, I get 4, but then I need to do the same thing to my numerator. And if I times 1 by 2, I get 2. The same thing can be said for any of our other fractions. Let's say 2 to 8. I would times 2 by 8, times 2 by 4, and I would get 8. If I times 1 by 4, I get 4. So we need to be doing the same operation to both the top and the bottom in order to keep that fraction representing the same amount. So if I have a look at this first example here, I have the fraction 4 over 5, and I want an equivalent fraction that has a denominator of 15. Now I can see that if I times 5 by 3, I'm going to get 15. And so if I do the same thing on my numerator, I will get the corresponding or the correct numerator to make this equivalent. So 4 times 3 is 12. Now if you type 12 divided by 15 on your calculator, remember I've said this before, will always automatically give you the simplified fraction. So there's my 12 divided by 15. When I say equals, it gives me 4 over 5. It is the equivalent fraction to what I started with. So if I have a look then at my next one, whoops, I've got a numerator now of 24. I know that if I times 4 by 6, I will get 24. So if I times 5 by 6, I will get my denominator, which is 30. Again, if I type 24 over 30 on my calculator, like that, I get 4 over 5. It is the equivalent fraction to what I started with. Right, so I want you guys to I want you guys to try B for me. So find those equivalent fractions to 7 over 8, where the numerator of one is 84 and the denominator of another is 40. So see if you can do those for me. You can put your answers in the chat. I don't want any hands raised just yet. I will tell you when I do, but I want you to try B for me. And like I say, type your answers in the chat for me. Remember, guys, you need to perform the same operation to your numerator as you do to your denominator, or the same operation to your denominator as you do to your numerator. We need to keep those fractions equivalent. We need to keep them representing the same thing. So we need to do the same operation.
Just is it okay if we can write a letter there? Let's say maybe that's an A, and then the answer there is a B, just to label them so we can know what is. Yes, thank you. I'm going to
use X and Y just because I've numbered my questions A and B. Okay, so guys, in the chat, you can say X equals, and then you can say Y equals, and then we know what you're talking about. I didn't think of that. Thank you.
Let's go, my people. Let's go. Remember, you write it on your book first, and then you can put it on the chat, okay? And we are using X equals to Y equals to, okay? Let's go, my people. We can do this. Can see y'all are working hard. Let's go. Nomsa, which I know that name, it's not your name. Probably it's an adult's name, but I can see you. I hope you are working. Hey, Mugai, Nomsa Zimandi. Definitely that's not your name. I'm sure of it. There we go, Kanya. Let's go. Remember, guys, we're using X equals to Y equals to, okay?
I'm liking what I'm seeing so far, guys. Well done. Just looking for some Y's there.
Lisero, I want to see your answers on the chart. Lisero looks so chilled. Hey, Lisero. I can see you. Yes, the one that is smiling right now. You. I'm talking to you. You have to put your answers in the chat. Let's go. Write them down. Let's go, my people. Remember, no hands yet. So whoever's hand is that, put it down, please. No hands yet, my people. Let's go. Ella, I want to see your answers also on the chat. Lydia, your answers, Miguel, your answers. Princess, let's use X and Y, because when you say A equals 2, I won't know what that is. There we go. And now we can see some Y's coming. Let's go, my people. Y'all are doing really good. Yeah.
Alrighty, let's do this. So if anyone would like to raise their hand now to tell me what the answers for X and Y are, you can raise your hand. Okay, Muvuyo, tell me, what is X?
X, ma'am, is equals to 96.
Okay, and Y?
Y is equals to 35.
Perfect, well done. Okay, so guys, let's just chat about why that is the case very quickly. If we look at 7 times what gives me 84, 7 times 12 gives me 84. So that means I need to multiply 8 by 12. And 8 times 12 gives me 96. Oh, excuse me, I'm so sorry. It just came out of nowhere. Okay, so that's the first one. Next one, if we now look at 8 to 40, we know that if we times 8 by 5, I'll get 40. So if I take 7 and times it by 5, I get my answer of 35 there for Y. So remember, whatever you do to the top, you need to do the bottom and vice versa. Right, so I'm going to wait there to take screenshots. If you have a question, now is the time when you can raise your hand to ask me a question. So if you have questions, raise your hand. I can help you now. Otherwise, you're taking a screenshot. And then we're going to take our little brain break before we carry on. Oh. Came out of
Let's
nowhere.
go, guys. Well done. I guess everyone got 100% for this question, right? We're all good. It's thumbs up, all of us. Please do vote on the chat. Let's see. Out of, no, let's just do thumbs up, thumbs down. So if you understand now, more or less, this concept, thumbs up. If not, thumbs down. If half, thumbs up and thumbs down. Okay, let's go. Let's do this, my people. We are helping teacher Sam to know where we are. Well done, my people.
Just quickly, Brian, 7 can go into 84. So 84 divided by 7 is 12 on the dot. There's no remainder. So just double check your division there. Okay, generally, they should be able to divide or times in perfectly. So just make sure of that over there. Nice, guys. I'm seeing lots of thumbs up, which is awesome. So let's have a look then at our brain break. I'm assuming you all have taken your screenshots. Whoopsie, that was a bit of a excited scroll. Alrighty, so brain break for anyone who's new. It's basically just a little break from what we're doing. I generally put like a little math puzzle, a little something, and you have to try and figure out the answer. I'm going to make this a little bit bigger because we've been having some moments where we have not been taking note of the fact that there are 2 images together. And so I'm really just making an absolute mess of this. Anyways, so for example, in the first equation, there are 2 turtles. So just be careful of that when you start to do your working out. So what we want to do here, is we want to find what value a turtle is, a lobster is, and a fish is, so that we can determine what the final equation's value is. So what I'm going to do is I'm going to get you guys to give it a try. And then when I see the correct answer on the chat, I will call your name and hopefully you will feel comfortable explaining it for us.
Remember, we are looking for the final answer, my people. Final answer. Okay, where there's a question mark. So you're allowed to work it step by step, but only give the answer where the question mark is. Guys,
Yes,
never, but yeah, no, sorry, you can go.
I don't know what I was gonna say, so you can ignore me.
Oh, I was saying, guys, I'm also still working it out. Okay, I also don't know the answer. So let's go. Oh, now I know the answer. Teacher Sam just rescued me. Guys, now I know the answer. Let's go, my people. None of the answers that y'all gave is the correct answer. So, nope. We are looking at the final one. Let's go. It's a brain teaser, guys. It's supposed to like hurt your brain, and you're supposed to have that inside you, you know? It's supposed to do that. That's what brain breaks are for. Okay. And while you added, yeah.
This one at the end, that's what we want the value of. Alrighty.
Yeah. It's go, my people. So far, no one has the correct answer. But please do stretch. If you are new, go, do stretches. You can go to the bathroom quickly. And guys, we don't actually have time. So y'all have like about maybe 1 minute or 2 minutes left. Okay, so let's do this. Let's do this quickly. 30, nope, it's not. Let's do it.
Let's say we've got 1 minute. If we don't see the right answer, we'll carry it over till Wednesday.
Yep.
To Wednesday.
That's the role. Yep. Agreed. It's not 178. It's not 178, my people. It's not. Take it step by step, and you can do it as a homework. You can definitely take a screenshot and ask an adult. Consider it's not 300. No. You have to work it out yourself. You need to work it out. Nope, it's not 48. It's not 290. Our 1 minute is running out. It's not 120. It's not 108. It's not 456. That's way too far. It's not 666. It's not 1882. It's not 98. Not 432. No, guys, no. Hopefully you're taking your screenshots, because definitely this is gonna come back on Wednesday. Nope,
Okay,
you know I
guys.
love break.
Take the screenshot. And guys,
Exactly.
all of these things you can actually do without a calculator. So like the point of these brain breaks that I put up is so that you are testing like your ability to do maths without a calculator. So all of this you can do without a calculator. There aren't any values here that are too big or too confusing. So take your screenshot. We'll have a look at this again on Wednesday, but I am going to ask for answers on Wednesday. So make sure that you've got some answers for me so that you can give me something on Wednesday.
Yep.
Right.
Okay, guys, now we're stopping about brain break, okay? Let's forget. Let's come back to maths, okay? Forget it. It's done. Gone.
Gone. Right, there, it's actually gone. Alrighty, so what we are going to have a look at now is sort of now starting to work with fractions. And oh, sorry, I don't know what on earth happened. Starting to work with fractions, starting to understand how we go about using these fractions, etc., etc. Now, part of understanding fractions is actually understanding what the fraction is telling me. So in this example over here, I've asked which fraction is larger. Now, that might seem a little bit weird, but essentially I'm asking you which represents the larger portion. And this is now where this idea of having a common denominator becomes quite important. Because if we can make both of these denominators the same, basically what we are doing is we are saying that we have split each of the shapes, rectangle, circle, whatever, into the same number of parts. And so now we can compare. So if I have a look at these two fractions, when I'm looking for a common denominator, what I want is the smallest number that both 5 and 7 can divide into. So quickly on the chat, can someone type for me, what is the smallest number that 5 and 7 can divide into? So basically, what is your common denominator here? If that's a little bit easier to understand. Good, Brian, well done. So 35. If you struggle with that, guys, think about your multiples of each number. So 5, 10, 15. I've made missions for myself, but it's all right. when you write out your multiples and when you think about your multiples for each of these denominators, basically you want the first number that is in common with them, 7, 14, 21, 28. And as you can see, the first number that appears in both is 35. So that is my common denominator. I can make these denominators the same then. If I go and multiply 5 by 7, I will get a denominator of 35, but I need to keep my fraction representing the same part. So I need to multiply 3 by 7 as well. And we know that 3 by 7 is 21. Then I will multiply my 7 by 5 to make my denominator 35. But I must do the same thing in my numerator and times 4 by 5. Now 4 times 5 is 20. Now you can see that both of your denominators are exactly the same. And so we've got 21 parts and we've got 20 parts. So now we have to decide which represents the larger portion. Well, I would much rather have 21 out of 35 slices of pizza than only 20. So that therefore means that the 21 out of 35 is the bigger fraction. And so that means if we go back to our original fractions, the 3 over 5 is the larger fraction. And I always relate fractions back to food. If there are 35 cupcakes available to me, I would rather eat 21 than 20. So that is the bigger fraction.
Exactly. I was also thinking about that. I'm like, no, I'll never forget that. Pizza. You know how nice pizza is. I'd rather have 21 slices than 20.
Exactly.
Different.
Exactly. Okay, so in this case, the 3 over 5 is the larger fraction. All right, I'll stop here in case you want to take a screenshot.
We got this, my people. We got it.
And then we're going to have a look at some conversions between those mixed numbers and improper fractions. Right. 5, 4, 3, 2, 1. Screenshot's done. Wonderful. Right, so let's have a look at converting fractions. Now, honestly, your calculator does this for you, so you can use your calculator to check, but you need to be able to do this without a calculator. All right, so if we have a look at our first value here, quickly in the chat, what type of fraction is 4 2/3? We've spoken about some different types of fractions. What type of fraction is it? Quickly type it in the chat for me. Oh, sorry. Nice, guys. It is a mixed number. Okay, there's a whole number part and there's a fraction part. So it's a mixed number. What we therefore want to do is we want to convert this mixed number to an improper fraction. So that means that we want a fraction where the numerator is bigger than the denominator. Now, in order to do this, there's a little trick that we can use to convert. Now, the trick is, you take the denominator and you times it by the whole number. So we will say 3 times 4, which gives me 12. And then we take our answer and we add the numerator. So 12 plus 2, which is 14. And so my improper fraction that I'm working with here is 14 over the original denominator of 3. Now, if we think about this mixed number and what it actually means, and you don't have to draw this if you don't want to, I'm just going to show you how we actually get to this. We have got 4 whole parts. So there's 1. I've really made some missions for myself, but it's fine. We move. There's 1 part. 2 parts. See, look at all these missions. 2, 3, and 4. So they're my 4 holes, but I've also got part of the 5th hole that we need to work with. Now, each of these are split into 3 because that was my original denominator. So I can split my rectangles or whatever you want to draw into 3 parts. And the 4 wholes, so that whole number in front there is the complete shading of 4 of these. My fraction part, so that 2/3, is then only 2 blocks in the 5th rectangle. Now, if I count how many blocks I've colored in, I've got 3, 6, 9, 12, 13, 14. So there's my numerator out of the 3, which is my denominator. Alrighty. So I wouldn't suggest drawing the blocks because, as you just saw, it's a bit time consuming. But if we break it down into what our mixed number represents, we can get what our improper fraction should be. Alrighty, so improper fractions, you times the denominator by the whole number, and then you add on the numerator. And that will give you what your numerator of your improper fraction should be, and the denominator is then the same as the original. Right, so if we have a look then at converting between, if we then have a look at converting from an improper fraction to a mixed number, what we want to be able to do here is we want to be able to see how many times our denominator goes into our numerator without a remainder. Now, there's many different ways that you can do this, but I like to sort of think of my multiples. So 6, 12, 18, 24. Now, I'm dividing by 6. That's why I've listed my multiples of 6. Now, what we can see is that 1 whole would be 6, 2 wholes 12, 3 18, and so we keep going. So we can see that my numerator sits somewhere between 18 and 24. So I definitely have 3 wholes, but I don't have a complete part of the 4th. Now, I know that 3 wholes represents 18 in my multiples of 6. So if I say, okay, well, how do I get from, oh, that's the wrong way around. How do I get from 18 to 22? Well, from 18 to 22, I add 4 parts. And so this allows me to get my fraction 4 out of 6. Now, we always want to try and simplify as far as possible. And because 4 over 6 can be simplified, I can simplify this to 3 and 2/3 because both 4 and 6 can be divided by 2. But essentially what you're able to do by figuring out how many times 6 can divide into 22 and then figuring out what your remainder is, you are able to get your improper fraction. Now, again, you can check yourself on a calculator. Your calculator does do all of this for you. If you type 22 over 6 onto your calculator and you convert it, it will tell you what the mixed number is. But we need to be able to do this without a calculator. And so understanding these methods is very important. All right, so I'm going to leave it there to take a screenshot.